Namaste everyone, welcome back to my YouTube channel. Today I am going to present the topic 4-stroke petrol engine. As you know all, I am Jyoti Monar Budale from Sri Venkateshwar College of Engineering. My ASN number is 23CS2021 and the subject is Introduction of Mechanical Engineering and the subject code is BECK104D and the topic is 4-stroke petrol engine. The highlights of my presentation are following. First topic is Introduction of 4-stroke petrol engine. Second topic is Steps of combustion in 4-stroke petrol engine. In that there are 4 stages. First one is intake stroke, second one is compression stroke, third one is power stroke and the last fourth one is exhaust stroke. The third topic is 4-stroke cycle and overview and the last one is applications of 4-stroke petrol. First we will start with the introduction of 4-stroke petrol engine. A 4-stroke petrol engine is an internal combustion engine that utilizes 4-stroke distinct piston strokes, intake, compression, exhaust to complete one operating system. A complete operation in a 4-stroke engine requires 2 revolutions of a crankshaft. The steps of combustion in 4-stroke petrol engine are following. Step 1 is intake stroke. Air and fuel enter the small engine through the carburetor. Step 2 compression stroke. Just after the piston moves to bottom of its travel bottom dead center, the cylinder bore contains the maximum air-fuel mixture possible. Step 3 is power stroke and step 4 is exhaust stroke. It is the diagrammatic view of 4-stroke petrol engine. We will go through the names of parts. First one is exhaust camshaft, it is exhaust valve, it is cylindrical head, it is combustion chamber, it is piston and connecting rod, it is crankshaft, it is cylindrical block, it is fuel injector, it is intake valve and it is intake camshaft. Our first stroke is intake stroke. Intake stroke, also known as induction or suction. This stroke of piston begins at top dead center, it is called TDC, and ends at bottom dead center, it is called BDC. In this stroke, the intake valve must be in the open position while the piston pulls an air-fuel mixture into the cylinder by producing a partial vacuum or negative pressure in the cylinder through its downward motion. The next stroke Second stroke is compression stroke. During this stroke, the compression of fresh drawn charge takes place by the return stroke BDC to TDC of piston. During this stroke, both inlet and exhaust valves are closed. As the piston moves upwards, the air-petrol mixture in the cylinder is compressed adiabatically. The pressure and the temperature of the charge increases and this is shown by the curve BC on the PV diagram. When the piston reaches the TDC or just before the completion of compression stroke, the spark plug ignites the charge. The combustion of fuel takes place at the constant volume and it's shown by the line CD on the PV diagram. The compression ratio in petrol engines ranges from 7.1 to 11.1. Next stroke is power stroke. At the beginning of the stroke, piston is in TDC and during the stroke, piston moves from TDC to BDC. During the stroke, both inlet and exhaust valves remain closed. The combustion of fuel liberates gases and these gases start expanding. Due to expansion, the hot gases exert a large force on the piston and as a result, the piston is pushed from TDC to BDC. The power impulse is transmitted down through the piston to the crankshaft through the connecting rods. This causes crankshaft to rotate at high speeds, thus work is obtained in this stroke. Hence this stroke is also called as working stroke. Also gas expands and does work on the piston, so this stroke is called an expansion stroke. The expansion of gases is adiabatic in nature and this is shown by the curve DE on PV diagram. As the piston reaches the BDC, the exhaust valve opens, a part of the burnt gases escape through the exhaust valve out of the cylinder due to their own expansion. The last one is exhaust stroke. At the beginning of the stroke, piston is in BDC, and during the stroke, the piston moves from BDC to TDC. During this stroke, inlet valve is closed and exhaust valve is opened. As the piston moves upward, it forces the remaining burnt gases out of the cylinder to the atmosphere through the exhaust valve. This is shown by the line EB and BA on the PV diagram. When the piston reaches the TDC, the exhaust valve closes and this completes the cycle. In the next cycle, the piston which is at TDC moves to BDC, thereby allowing fresh charge to enter the cylinder, and the process continues. It is the PV diagram of 4-stroke petrol engine. We will go through the symbols, in which 5 to 1 shows the suction of air petrol, 1 to 2 shows the compression of mixture, 2 to 3 shows the constant volume combustion, 3 to 4 shows the expansion stroke, 4 to 1 shows the exhaust valve opens, and 1 to 5 shows the exhaust of combustion product. 4-stroke cycle and overview. It is a clear picture of cycle of 4-stroke petrol engine. With the cycle of 4 stages, we are going to complete the process of 4-stroke petrol engine. The last one is application of 4-stroke petrol engine. Petrol engines have many applications including motor cars, motorcycles, aircraft, motorboats, small engines such as portable engine, generator and chainsaws. The last one is conclusion. A 4-stroke engine is an internal combustion IC engine in which the piston completes 4 separate strokes while turning the crankshaft. A stroke refers to the full travel of the piston along the cylinder in either direction. In this way, today we have completed our topic 4-stroke petrol engine. I hope you like my video. Please do like, share and subscribe. See you in next video. Thank you.